Good morning, my dear students, colleagues, and subscribers of this channel. After measuring the linear relationship between two quantitative variables in the earlier video, in this video, that is in video number 570, I'm going to measure the difference between means, and there are three different types of t-tests. So in this particular video I'm using one sample t-test. In the coming two videos I'll be using independent sample t-test and pair sample t-test. So let me start with the analysis of one sample t-test. So the formula for the one sample t-test is given here, where t is equal to x bar minus mu whole divided by standard deviation divided by square root of sample size. So let me explain this. This formula calculates the one sample t-test or t-statistic, which is used to determine statistical significance of the difference between a sample mean and a hypothesized population mean, where mu is the population mean, x bar is the sample mean. Let me explain this. T is the test statistic. For the one sample t-test, x bar is the sample mean, which is the average of the data points in our sample. Mu is the population mean, which is the hypothesized or known average of the entire population that we are comparing to our sample. Small s is the sample standard deviation, which is a measure of the spread or variability of the data in our sample. Square root of sample size, that is square root of n, is the square root of the number of data points in our sample. In essence, the t statistic is a ratio which compares the difference between our sample mean and the population mean mu to the variability within our sample. A large t statistic, either positive or negative, will indicate a greater difference between the sample and the population means relative to the variability within the sample, and thus a higher likelihood of statistical significance. So after describing how we can use one sample t-test to measure the difference between a sample mean and a population mean, I'll use my data set that I have already opened here. So for the sake of convenience, let me use this variable, which is marks in statistical analysis and interpretation, and the total number of observations in this file or the variable is 110. So let me navigate to analyze and go to compare mean and then one sample t-test, because I'm going to compare the sample mean of this variable with the population sample. Let me suppose the hypothesized or the known value of the population mean mu is equal to 48. So the test value is 48. The mean of the sample of this variable is not yet known. So I want to test the difference between the mean of this variable, that is marks in statistical analysis and interpretation, with the hypothesized value of the population mean, which is equal to 48. So if I click on OK, it says one sample statistic. So the n is 110. A mean of the marks in statistical analysis and interpretation is equal to 53.7364, and the standard deviation is equal to 9.90846, and this is the standard error of the mean. In the below table here, the t value is equal to 6.072, and degrees of freedom is n minus 1. So n is 110. So 110 minus 1 is 109. So the p value of the total p value of the t statistic, one sample t statistic, is 0.000, and this is a difference between the mean, that is the difference between the sample mean and the population mean. The population value that we hypothesized was 48. So using these values in the formula here, in this formula, let me show it to you. The sample mean is 53 point something. The population mean, hypothesized population mean, was equal to 48, and standard deviation was equal to 9 point something, and n is 110, so the square root of n will be used. And if we simplify that, then the t statistic is equal to this value that we just found here in SPSS, and that is equal to 6.072. So if you look at the observed p value, which is less than 0.05, so we reject the null hypothesis, and the null hypothesis is that there is no difference between a sample mean and population mean. So we can say that x bar is equal to mu, and the alternative hypothesis is that x bar doesn't equal to mu. The predetermined level of significance is 5%. Test statistic is one sample t state, and decision criteria is that if this observed p value is less than 0.05, so we will reject null hypothesis. Since this is actually less than 0.05, so we reject the null hypothesis, and we conclude that the one sample t statistic is statistically significant, and we can say that the population mean is different from the sample mean is different from the population variance, and the difference between the two is 5.73636. So the conclusion is that we reject the null hypothesis of no difference between the sample mean and the population mean, and we conclude that the sample mean is greater than the population mean by this amount of 5.7363. So ladies and gentlemen, this is a very informative and useful video for those who don't have sufficient background in statistics and they want to analyze their data using t-stat. So kindly share this video with your friends, with your colleagues, and share videos of this channel in various WhatsApp groups so that they could reach to the maximum possible number of people. Thanks for watching.